Okay, so we are going to do some notes on momentum and practice solving the math problems. This shouldn't be too tough because we have done these types of math problems since the beginning of the year, and we're just throwing some different variables in, and we'll be continuing to do the same process that we've done with all of our story problems. So let's talk a little bit about the concept and vocabulary with momentum, and then we will solve some problems. So you're gonna have to excuse my awesome band-aid I'm wearing. I think it's Ryan's World or something. I sliced my finger at the tip of it. You can't really see it very much. There it is. Pretty deep. Looks okay now, but I took a big slice off the top with some glass on accident. And this was the fancy band-aids we had. And then I went and continued cleaning and took a shower and kind of did a workout. So it's looking a little rough. And I don't have another band-aid right now. And so I'm keeping it on because the way I hold my pencil, I put pressure with that tip of my pointer finger, and I don't want to open it back up again and ruin this video or my notebook with what might come out of that cut. So excuse the really weird, funky band-aid. Okay, so anyways, what is momentum? So momentum, it's actually kind of hard to write because I don't want to put too much pressure on my finger. So if I write sloppy, I will do my best to clarify what it is. Momentum. Momentum is the product of mass and velocity. So we already kind of know that because we've talked about it. We did some stuff on it already with the reading, the CK12 reading. We also did a little sled war simulation where we were talking about mass and velocity. So you should know that by now. Product means we multiply it. And it is a vector quantity, which means direction matters. Okay, so direction matters because velocity also has a vector. So therefore, if velocity is in a specific direction, if we multiply mass times velocity, that means the object has a specific direction. So it does matter when we're talking about positive momentum and negative momentum. With this beginning stuff we're going to be doing with just using mass and velocity, we aren't going to worry too much about the vector or the direction. We're just going to be multiplying the mass and the velocity. Unless I do give you a direction, like they're moving east or west or right or left, then you would have to report that direction in the problem for your answer. But when we get to collisions, we're going to be talking about objects moving towards each other, which means they're going to be moving in different directions. That's when you're going to start really seeing positives and negative velocities, and therefore your momentums will be positive and negative as well. Okay, so just remember that. So let's talk about the equation. The equation for momentum, we already talked about how momentum is not m, it is p, okay, equals m for mass multiplied by v for velocity. So p will be momentum. I'll write it down small underneath. M is mass and v is velocity. So that would be what we need to use as our base equation. So luckily we do have a circle for this equation. Momentum goes on top, mass and velocity go on bottom. So I'm going to use my left hand here so I don't have to use my band-aid finger. If I want to find P, momentum, cover it up, and I get M next to V. There we go, mass times velocity. If I'm looking for mass, I cover up M, and I get P divided by V. And if I cover up V, if I'm looking for velocity, I get P divided by M, or momentum divided by mass. Okay, so remember, that's how we use the circle if we need to rearrange the equation. All right, let's talk about units. Units matter, remember, and they always work out for however the problem is set up. We always end up with the correct units, and that's what's important. So we've already used mass a bunch of times, so I'm just going to put that down there as kilograms. We've also used velocity and talked about that a bunch of times, which is meters per second. Now, when you multiply two things, they're going to end up And the same, or together, kilograms times a meter per second is going to give us a kilogram meters per second. That's our momentum unit. Now, we just did one where we did mass times acceleration. That was force. Mass times acceleration was a kilogram meters per second squared. We got a kilogram meters per second squared, and we called it a Newton instead. But momentum is a kilograms meters per second, and we do not call it or change it to anything different. So every time you write out momentum, you're going to find that you're going to have a unit of a kilogram meters per second. Okay, so let's talk a little bit about proportionality. So we've done and talked about proportionality in the force equation. So same thing goes with momentum, because notice you have two variables being multiplied to equal another variable. That means you're going to have things that are directly proportional. Okay, so let's talk about that. Momentum is directly proportional to both mass and velocity. So it's directly proportional. And remember, directly proportional means if one goes up, the other goes up as well. So if mass goes up, momentum goes up. So the object gets more mass, the amount of momentum it has is going to rise as well. Same if it goes down, the other goes down. Okay, now velocity is also that way with momentum. It's directly proportional. So if velocity of the object goes up, then momentum goes up. So in our sled wars demonstration, when we raised the height of the sled, it went faster down the hill. So the velocity went up. And you notice the momentum also went up as well. When we changed the mass of the sledder from 50 to 100, the mass went up, momentum went up as well. Okay, so if you double mass, okay, then the easy way to think about it is you double mass, momentum will double. So momentum doubles. And then that's the same with velocity. So if velocity doubles, then momentum doubles. I'll just write that down there. Anytime things are directly proportional, if you double one of them, you're going to get the other variable will double as well. So let's talk about what if we double both. So if you double both mass and velocity, then what do you think momentum will do? So you've doubled both. You now doubled mass, you doubled velocity. What would happen to momentum? What will happen is then momentum quadruples. Because it's directly proportional to both. So you could do a little test just by thinking about it. Like take a really, really easy number to double. Say we had a mass of 2 kilograms and a velocity of 2 meters per second. If I multiply 2 times 2, I'm going to get a momentum of 4 kilograms meters per second. Now, what if I double the mass and double the velocity? Well, doubling the mass is 4. Doubling the velocity is 4. Well, 4 times 4 is 16. I just quadrupled the momentum. So anytime we want to look at any of these rules, you can just test them by throwing some numbers in there. I'm going to erase these so they don't get confusing in my notes. But just throw some numbers in there and do a quick little test run, and you should see that your rule should work out. Okay, so that is the proportionality part of it. All right, so let's talk about some practice problems. What happens when we have a real problem and we need to solve for it? So this should be pretty easy, like I said, because you've done this all before. So let's try, what is the momentum of a 60 kilogram linebacker? Whoa, not a linebacker. They are a linebacker. There we go. Moving 9 meters per second. So the linebacker is running. They are 60 kilograms of mass and they are running at 9 meters per second. So we have underlining what we are given and what is the momentum. We're going to circle what we need. So remember, that's kind of the method we use. Underline what we've given, circle what we need. So we also need to pull out our variables. Our variables we're going to use are P, M, and V. So I'm going to write those variables down here, P, M, V. We're given a mass of 60 kilograms, so I'm going to plug that into the variable for M. We're given a velocity of 9 meters per second, so I'll plug that variable in there for V. And I'm looking for momentum, that's going to be my X. And remember, momentum is found in a kilogram meters per second. And now I'm going to be using my base equation, which is P equals M times V, because I'm looking for P. And I'm going to plug it in. So P is kilograms meters per second. Sorry. That pointer is really making it hard for me to write clear. You forget how much you need some of your fingers, and it's just a little tiny, well, it's a deep cut, but hurts. Okay, mass, 60 kilograms. That's my M, and my V, I'm going to multiply that by 9 meters per second. So 60 times 9 is what I'm using, and I'm going to just do that exactly in my calculator, 60 times 9, and that's going to equal, there we go, 540. And remember, it's a kilograms times a meters per second, so it's a kilograms meters per second. Really simple, just multiply. Okay, let's try one looking for a different variable. So number 2, what is the mass of an object with 75 kilogram meters per second of momentum moving 15 meters per second? Okay, so this time we have an object with a momentum of 75 kilograms meters per second, and it's moving at a velocity of 15 meters per second. We are looking for the mass. So we now need to find a different equation. We're going to look for M, but before that, let's write out our variables, P, M, V. That's all the variables of the equation we need to look for. We're given this time 75 kilograms meters per second for our momentum. We're looking for mass. That's going to be X, and our unit for mass is kilograms. And our velocity is over here at 15 meters per second. So what is the equation? That's the question. Well, let's go look at our circle. If we're looking for mass, cover up the M, and you're going to get P, or momentum, on top of V, velocity, or P divided by V. So I'm going to write that down here just so I remember. Mass equals momentum divided by velocity. And now I'm going to just plug it into the equation. So M, mass, X kilograms, equals, my momentum goes on top, so 75 kilograms meters per second. I'm going to divide that by my velocity on bottom, 15 meters per second. And now here's a perfect example of how you can see how we get those units. What do we have the same on top and bottom? We have a meters per second on top, meters per second on bottom. We're left with a kilogram. That is what we need. See? And that's how we know we're doing it correctly. So if I were to plug 75 divided by 15, you might be able to do this one in your head, but just for sake of showing you, 75 divided by 15 is going to be, there it is, 5. So my answer is going to be 5 kilograms. That's the mass of the object that is moving at 15 meters per second with a momentum of 75 kilograms. Okay, pretty easy so far, right? So let's do one more where we're looking for velocity. I have to change pages. So since I was on 17 before, remember I'm a little bit behind you guys because I don't write everything in my notebook like you should be doing. Hopefully you're keeping up your notebooks just in case we come back. Okay, 18 is my new page. I'm still on 111 or 12, 112. Depends on which day you're watching this. Okay, whoops. I gotta adjust my camera really quickly. There we go. All right, so we're still doing momentum notes. So I'll write that as the title so I remember when I'm looking at it what the heck it is. So we already looked for momentum. We already looked for mass. How about we look for some velocity? So the last one we're going to do is, what is the velocity of a 1,600, so 1,600 kilogram car with a momentum of 48,000 kilograms meters per second. So we have a car, it's much bigger than the other objects we've talked about, or humans, right? So it's a much higher mass, therefore it's going to have a much higher momentum at 48,000. Now we need to find out what the heck the speed it was going. So we're going to look for velocity. So I have momentum, I have mass, underline both of them. I'm looking for velocity. And I still need a P, an M, and a V, so I'm going to write my variables down just like I do every time. Since I'm given my momentum at 48,000 kilograms meters per second, I'm going to write it down. I'm also given my mass at 1,600 kilograms. And I'm looking for velocity this time. So it's going to be X, and my unit is going to be meters per second. So I do need to find out my equation. And some of you might now be just sort of memorizing how the circle works. If you are one of those people that can visualize it, anytime we have a direct equation like this, something equals one multiplied by the other. So when the two variables are being multiplied to equal something, the answer or the product will be on the top. So whatever one is on top is always the product when the other two are being multiplied. So that's a kind of way to think about it when you're thinking about the circle. So no longer do I have to go and cover up that. I just think, oh yeah, momentum equals mass times velocity. So momentum will always be on the top of the circle and therefore on the top of the equation. But for sake of just doing it again, if we're looking for velocity, we cover up V and we have P on top of M. So momentum divided by mass. And let's go ahead and write that out just for the sake of being able to see it. So my velocity equals momentum divided by mass. And now I just plug these numbers into this equation. So velocity is x meters per second. That's what I'm looking for. Equals my momentum is on top. So my momentum is the big number, the 48,000 kilograms meters per second. My mass is on bottom, 1,600 kilograms. So again, what cancels? What's the same on top and bottom for the units? Kilograms. Goodbye kilograms on top, goodbye kilograms on bottom, leaves us with meters per second. That's what we need, so we're on the right track. Now we just divide, okay, and we'll go 48,000. Whoa, that's too many zeros. Try that again. 48,000 divided by 1,600 equals 30 meters per second. So the car is traveling at 30 meters per second to give it a momentum of 48,000 kilograms meters per second. Okay, and that is it. So the next thing you'll be doing is a worksheet that's going to practice all of this.